Alright, hello. So, I'm gonna continue with this. I thought about this and I think there's actually some problems with the way I'm thinking about doing this, this volume system. So, my issue is that with this current weight system, you would make one very big volume that would be like your default settings, and set it to a very small weight, like 0.01, and then you would have like your actual settings in an area that has like 1, and that it weighs way more than it, but it never 100% sets it to your settings. And so like, I guess you can account for that in the settings, so it doesn't really matter that much. Yeah. Hello, Misarilev. Misarilev. Just Lev works, alright. So I need to do similar to what I did right here and calculate the attenuation relative to the scale. Custom render pipeline sounds interesting. Yeah, it's one of the lesser documented areas of Unity. I actually have most of the render pipeline already set up. I'm doing deferred rendering. These gradients are the world position being visualized, but it's doing this with deferred rendering, which is pretty nice. I previously did a custom lighting system in Unity 5.3, and you actually weren't able to get your own custom deferred rendering working in Editor because it wouldn't give you the proper callbacks. So this is nice. So the local position relative to the property volume is just, I'm actually not sure if it's negative 0.5 at each extent. I should actually check that. So I'm debugging this by debugging this position relative to the volume, and then I'm going to put the camera right on the edge of the volume. Yeah, I think it's at 0.5. Yeah. Very intense music. Is it that loud? Nice, okay, 0.5. Oh yeah, and one thing I was thinking about is, especially for lights, I'm gonna want to do this render camera, but only render the G buffer. I just need to. I don't think I'm gonna do that right now. I think I'm gonna finish this property volume system, and then I'll do that. I'll do that when I work on the actual lighting. So, this is the position, and we can use this same scaling to get the relative distance. So does vector 3 have abs, have an absolute value? No, they don't. Okay, so I'll do that when I measure the distance. Oh, I mean to subtract 1, I'm actually going to need to do that. Does it have a sign? No, interesting. Okay, well, I'm going to make that in my utility function. Actually, it is. No, it doesn't have divide either. That doesn't have divide either. And so none of these have sign. Okay, well, I'm going to implement these functions. Is there a way to, like, implement operators outside the class? I don't think so. C#, add functions to existing static classes. I know you... I feel like this is possible. Extension methods require an instance value. Ah, okay. No, okay, that's what I thought. Can I just name these all divide vector and it'll automatically... Do I name it vector divide? I think I name it vector divide. It seems to make more sense with like vector abs too. This is where replace comes in handy. Alright, now that we have the box position, we can then scale it by our attenuation range back up to world space, and then take the length of that. So, oh yeah, also change this function. I'm just thinking, do I do this the same way? In this case, I was converting the world space attenuation range to local position, and in this case I'm converting local position to world space. So I actually think I'm scaling. Right here. Maybe it's actually minus 0.5 instead of 1. Then we'll move our camera 3 units away. Oh, yep, it's working. Wait, almost. This time it should be like 2.7 units away because of the 2.9. I wonder... No, it seems to be working. Alright. It is measuring the distance to our volume right here. So now we can apply the attenuation and the weight. I just feel like going outside the property volume shouldn't reset to nothing. I guess what I'll do at the end is if total weight is 0, then I'll just set everything to 1. Or like default settings or something. Hey Unicomp, how's it going? Back with motivation? I don't know about that. But I'm still going. That's a big one-liner. I think it's good though. And we just convert the distance to weight. I wonder if there's like a Unity editor for a dictionary. Because what would be better than an array here would actually be going by tag names. I don't need exactly a dictionary with all the different customizable types. I just need it with strings, or even like a hash map, I guess, but I guess this will work. But I'll need to track weights for each custom. So in this case, the developer would have to actually like line up put these custom values into an array and keep track of their index, which is really stupid to do in the editor. So I actually do want something like a dictionary. I guess I could just do 2 arrays. I could do 1 array here and then 1 with string names, and then handle the dictionary myself. I honestly feel like that is the way to do it. Nope, doesn't seem like there's any simple way to do that. I wish there was a way to do this in Unity. It seems like they should have something for key value pairs. key value pair serializable. I guess I could create a class. Oh, can you not use... You probably can't use generics on scriptable objects. Yes, but the scriptable object can't be generic itself. Okay, I think I can just do it as a system.serializable then. Will this work? Appears that the string isn't serialized. What about this? Weird, it's only doing the vector 4. not the string key. Oh wait, I'm dumb. Put this under the wrong thing. Okay, so now it doesn't appear. I guess you can't use generics in Inspector. That's no longer using generics. Does not support serializing generic types. Alright, that's the answer I needed. Solution/workaround. Create a subclass that has explicit type. Yeah, I think if you inherit scriptable object, it actually should work. Let's try. No. So I'm just going to create it as a class here, I think. There we go, finally. Okay, so now we can keep track of these custom values in this dictionary. Oh yeah, and I learned 4 is actually faster than 4 each. Did YouTube pause it? The hell? YouTube, please give me related music. This is not related music. I actually think like YouTube isn't working because I press the different buttons of things to suggest and it literally doesn't change what's in my suggestions. Okay. That works. Okay, so I'm actually going to need a weight here as well, I just realized. Oh, this is conflicting, because actually I don't want to serialize this, but I want it to be shown in the editor. Oh no, I just realized. I don't want this to be saved. I don't want these to be saved. Is weight gonna show up on here? Oh no, weight is gonna show up on here. Oh my god, so this is... That's not good. Okay. Oh my god, so I'm gonna need I'm gonna want 2 different classes. I'm gonna want one with weight. Oh yeah, so what's the most effective way? Try get, I think. Is this what psychedelic rock is? Alright, here we go. So now I just need to loop through this at the beginning and reset all these weights and values to 0. I'm actually kind of tempted to do a little benchmark. I want to see what's faster with dictionary, for each or is dictionary for each faster? Fastest way to iterate over it, comparing 3 options. For each. Values collection. Get keys alone. Or key value pairs over keys. So keys collection is actually fastest. Faster than for each. We'll allocate a value collection for eaching results in a call to get enumerator. We allocate on the stack. Yeah, so I think for each is actually better for dictionary. For each, I think. C# loop only for each only values in dictionary. I don't get how this doesn't do an allocation. Wait, how do I even access? For each. I'm just doing key value pairs. actually normalize these at the end by the weight. I wonder what I should do. I actually wonder if I should do a default. Just like in the asset here, I have defaults. What if I did custom property defaults? If we don't have any weighted volumes, we're just going to set them to the default exposure. This should maybe be a dictionary so that I can easily look it up. But it's not. Instead, I'm going to need to search through it. I'm just thinking if that... I guess that's not a huge deal. Alright. So let's test this now. What should I call this? K. And then we'll set it to 1, 2, 3, 4. And then in the property volume, have another K, except we'll set it to 3, 2, 1, 0. So then when the camera is anywhere in this volume, it should be set to 3210, but when it's outside, it shouldn't be set to anything. So right now it's out, so it should be set to 1, 2, 3, 4. So if we go to our, we can view these properties under, well, we should be able to view them under cartoon render properties. But apparently I'm an idiot, and I've done something wrong, because they aren't showing up. Props.custom. Oh, because they're a dictionary. Of course. I need to actually get it with code. Okay, so wait a minute. If kv.key equals k, k equals value. Nah. Okay. This is why we test things. This is why we test things. It also should have been a really good hint for me that this exposure, ambient, near, ambient, far, and far distance is all blank and not being set. Ah, that is because I've not set it. Ah. Alright, so what's it doing here? Total weight. Ah, total weight infinity. Okay, so this is a weird bug. Normally stuff breaks in the scene view and works in game mode. This time it actually works in scene view and then breaks in game view. Interesting. It's flipping it around. So why would magnitude be infinite? Oh, attenuation range. Oh. Oh. I know what I'm doing. I'm kind of attenuating this backwards. I guess I can just do this with min and max. go. There we go. 1, 2, 3, 4. Okay. So now if we put it in, the weight should go up to 1, and we should get 3, 2, 1, 0. Three, 2, 1, 0, and total weight 1. Perfect. Alright. Wait. Does this actually measure it? Like if I go inside this. No. So I guess it's just default in the editor. Alright. That's the custom volume system. Done. Alright, I'm really happy with that. So that's like a base that can be used for so many effects now, like volumetric fog, just a bunch of stuff. Changing, yeah, things like fog values. I might actually put, oh my god, I just realized I haven't done any planning yet for how I want to do fog in the engine. So my thought's kind of been, because it's deferred, you can always just add your own fog. So like, what I'm thinking is if I do fog, I do it as an extendable thing that isn't always on, because other people might want to do your own fog solution. And see, that's actually the really nice thing about these custom properties and the volumes, is you could set one of these custom properties to fog and then have the volumes change the amount of fog in your area. But then it's like, yeah, so like Unity, for example, has built-in fog, and that is like the standard graphics fog that is like exponential, linear, exponential, squared. And so I could do a basic fog like that. I feel like that might actually be a decent thing to add, because I can always have it be optional as well. Default fog is depth. I don't know, the default is, I think the default's exponential squared. But yeah, if I do built-in fog, I'm thinking how I would do it. Like, I almost feel like going and doing it like, that's the thing, it depends. So basic fog is like linear interpolation fog, which is basically like it just interpolates between the pixel value and what you want your fog value to be, and normally it's like the background. So basically your things gradually fade out to the background. I could do height-based fog, or like, which would be awesome. I feel like that would be the best thing. I'm actually thinking, because it's deferred, I just do fog volumes. Like, just do deferred After Effects where I Yeah, that's the best thing. Yeah, height-based fog, so it's like not just height-based fog, but doing fog as a deferred post-process, where you just basically like composite the fog on top of everything afterwards based off depth. That way you could do height-based fog, you could do spherical fog if you wanted to. Make it so complicated to make performance good. So my plan is to not do shadow gray marking. I'm not gonna step through shadows in any of the volumes. It's literally just gonna be fog. And my idea is doing fog volumes as actual objects would be really good, because then you can do streetlights and things that might have like glowing additive fog, but then might also be able to do like darker smoke fog. It actually takes away from the scene. Okay, I think I'm going to begin working on the lighting and some of the actual shaders now. Alright, I'll be right back. I'm going to go get some water and take a quick break before this. I'm thinking of changing up the music. I can only stand so much rock. It kind of starts to sound the same to me. Now this is different.
Look at the stars, look at the signs. This is the start of something new, the age of Aquarius. Here comes the sun, a glorious one. This is the start of new life, floating has begun. Stay close to the river. the fairies of the forest will come. They wanna show you to the dance of night. This is the age of Aquarius. Of night. This is the age of Aquarius.
So I had this system where it does ambient near light and ambient far light so that the light kind of changes almost like fog. But I'm almost thinking that's kind of stupid now and I should just do ambient. I think I'm just gonna do ambient. And now this color isn't gamma corrected. So I think to do it correctly, I guess I could put... So I was gonna just hard code the gamma there, but I'm thinking I might put the gamma in a define right here, so that you could potentially change it later without having to go through. I'm going to scale up the emission a little bit so that it's possible to make not bright colors bright. Actually have emission be different values. And then the ambient is already going to have gamma correct applied. When I set the value for the deferred material right here. Alright, so it's all black because there's no ambient light setting yet. And I didn't add an emission option to the shaders yet, so okay, let me add the ambient lighting. Alright, I'm gonna switch this. I am had enough of rock. Wait, I just realized this might not work. I might need to set globals. I might not, Compute shader, I need to set a non-global. Buffer, set material options. Oh. Alright, so I probably need to set material property block. Okay, I want an example. I think I'll need a different property block for each pass. Is there a way to get main texture ID? Texture, shader property. Oh god, is it gonna crash Unity? Oh, wait. This mix is shit. should be setting to the default ambient right here. What is ambient set to? 0. Wait, it's set to 0.1 alpha? What? Is it because it's getting converted to vector 4 or what? Yeah, I wonder if it's because I'm not casting it to vector 4. Because here when it's a color, it's the correct value. Unity color to vector 4. I thought they were exchangeable, like you could just cast one to the other. I might be wrong though. Colors can be implicitly converted to and from vector 4. Well, I feel like this is a lie because I'm trying to do it right now and it's 0. Maybe I have to do dot. Wait, no. I don't know. Huh. I'm assuming it's not POW. Wait. What is POW doing? Why is this, when gamma equals 2.2, setting the value to 0? Is POW broken? Unity mathf.pow returning 0. Wait, so now when I debug.log gamma, it actually works. Okay, so now it works. Constant gamma can't be marked static. I wonder if gamma was just being read as like 0 for some reason. Alright, well, it's outputting the correct value, and it's still not being set. Amazing. I wonder if it's because these are literally outputting 0. It might just actually be my standard shader. I might just be an idiot. Oh my god, I'm actually outputting 0. Oh my god. Well, there's our solution. Alright, and we got a new utility function to do, pow. Alright, that made me realize I actually need to set up this standard shader to do something other than just output a plain color so that I can start testing this better. Same time though, this doesn't look quite correct. Gamma inverse should be countering it, I think. Because pow, if color is 1, should still be 1. Multiplied by ambient.xyz, which is our gamma corrected color. Unity, our color's linear. Colors gamma corrected in the inspector. I wonder if this, where it's displayed, is actually wrong. Because it definitely looks dimmer. It definitely is dimmer. So what if I don't apply the gamma correct here? Is it too much? Yeah, so now it's too bright, I think. Does vector 4 to color do any conversions? I guess I could just debug this. No, it's the exact value. Okay. Okay, let's try and set up standard shader then. What is happening? I think I have a bug. because that does not look right. So let's set ambient to full. And let's debug this. Alright, there's definitely a bug going on there. So I'm definitely encoding the colors wrong. Kind of trippy. So somewhere right here, floor color.x times 50.999. Times 1 divided by 255. Scale it back. So 15. Oh, I floor and then multiply here, I think. Okay, it works. I think, wait. Yeah, so it has limited color precision because it's actually just 4-bit colors. But I did some basic calculations on it, and 4-bit colors still covers a huge spectrum. And the idea is to be a cartoonish engine, so it doesn't, I don't think it needs the full color spectrum anyways. Awesome though, okay. Just getting all these little things working is part of the trick. Okay, and that means I actually need to change. Actually, the decoding is still the same. No, the decoding is still the same. Alright, so now I think I'm going to do directional lights first. And I'm also going to need to set up rendering depth only, which will require changing up this. Either doing a separate function or adding a boolean. I'm thinking of actually splitting it into 2 functions. Render camera gbuffer, and that does this first part. Or actually, this can be handled manually in the rendering loop, but then you can render to like your own gbuffer, which in my case could be the shadow map. Like, I kind of don't want to do it until I get to shadows, because then I know exactly what I need. But I don't want to write all this, have this code copy and paste into separate parts. I think having an if statement and a bool is the way of doing that. But basically now, so this first ambient lighting pass is crucial, because this actually clips the background. But after this, we can basically just stack up as many deferred lighting passes or composition passes as we want, and they can be additive. You can do pre-multiplied alpha. So basically, like, additive passes, you can just add on lighting. If you want to add a custom light, I'm basically going to add a callback here where you can run your own shader and mesh across the deferred G buffer. So basically add your own lighting custom afterwards. But then it's not just like additive. You could do pre-multiplied blend mode where you make it darker like smoke. Or that's the crazy thing too, is like with Unity you have all the shader options available, so you could do like XOR blending and do some weird darkening instead of lighting. It's what I really like is that my huge complaint initially with the universal render pipeline, or my huge complaint with it and why I really was disgusted by it, was that there's like no customization. I could not create my own shaders easily at all. You had to jump through a whole bunch of hoops. So my whole goal with this is to just make the shaders so nice. Like, so this is the standard shader. I feel like this is such a nice syntax. You've just got your vertex and pixel data, your small amount of properties, and I've got all of the deferred gbuffer stuff just packed into an encode pixel function. So all you do is you just pass in your depth vector, your color, and your emission, which are your surface properties, and it basically makes it kind of like how Unity had surface shaders, except it's just a normal shader. And you can do whatever modifications or whatever you want to the surface here, and then if you want to modify the lighting, you can do your own deferred passes, just like this ambient lighting. Alright, hold on, I'll be right back. I'm gonna get some water. I'm gonna think about this. I'm gonna do directional lights first. So I gotta think about, like, I'm gonna create my own class for a directional light, and I gotta think about how I want to organize that. Probably pretty similar to the volumes. I actually don't get why this isn't displayed. Oh my god, is it because the alpha? Yup, it's because of the alpha. Okay. So I guess I'm gonna start without shadows, and then I'll add shadows once I have the base directional light working. So the weird thing is with the directional light is, how do you define? So with the sphere light, you actually have a radius. And that's the actual size that determines, for example, like the penumbra and how close like the mesh is cut off when doing the shading, or like the area between darkness and light. But when it's so directional light is technically a sphere light that's very far away. So I guess with the directional light, I might just literally not do a sort of penumbra. I guess I could just call it size, I don't know. I'm actually wondering if instead of, for example, building up all these volumes here, if I should just congregate these all under the cartoon render pipeline, I feel like that would be most organized. Okay, so now we render the passes for this. So the directional lights are interesting because they're actually going to cover the whole screen. So I feel like I should almost do just this like static cube mesh rendering again. Like, maybe I should actually do the directional lights with the ambient lighting in a single pass, and that would be by far the most optimized. I'm really considering doing that. The only thing is it would limit the number of shadows, but I'm only gonna have like one directional light with shadows at most, too, and if I pass... Yeah. Basically, it'll just limit directional lights to like 8 or something like that, which isn't a big deal. Yeah, I think I'm going to do the directional lighting here. Pull the lighting pass, surface emission, ambient, and directional lights. I actually haven't calculated the normal yet. I'm gonna calculate low polygon normal using depth derivatives. Hopefully. We'll see if it works properly. I'm just realizing I can probably do this with a matrix multiplication. I'm basically typing out a manual matrix multiplication. It compiled, at least. Alright, definitely not working, at least so far. So I'm trying to get world space normal from depth derivatives. Yeah, screen space normals. My issue is calculating the amount of z. So, like, thinking about this, calculates the difference of the depth. So I'm actually wondering if it's actually working. It's just that with the precision of ddx and my depth buffer, if there's not actually a derivative to calculate from. Just copy the share from screen space decals. Let me look this up. I guess I should just start with like screen space. Also, I'm going to be calculating this for like each pass. And I'm wondering if I should just like, I should actually just calculate this to a separate buffer. But it shouldn't be too expensive. So I guess the difference in depth between these, which isn't actually just this projection param, it's also dependent on the screen resolution. So let's divide by screen params. Or maybe I need to multiply by screen params. Yeah, my depth is already linear. But you can see the normal is changing depending on what way I look at the surface. Which is not how it's supposed to work. So this forward is probably supposed to be backwards. And they also need to make everything negative. So these world space camera is technically the matrix. These forward, right, and up technically make up the matrix. I think my actual screen space normal is wrong. This NDX, NDY, and NDZ. So the blue is the amount of z, the red is the amount of x, and the green is the amount of the y derivative. So we can see the derivative showing up there. Oh, and you can actually see the derivatives. It looks like they're showing up on the sphere after a certain distance. So yeah, it actually might just be precision issues. This might not work. What if I take away NDZ? Yeah, but I think most screen space decals use the actual depth buffer that has like 24 bits. Oh no, it's working. Actually, it might not work. So you can see these lines. These lines are actually where the derivative can't calculate anything because it doesn't change because of the depth issues or lack of precision in the depth buffer. So this whole idea might not work. It might be insanely noisy and buggy instead. So I might either need to do my own depth encoding. So in here, in right here, I think what I would do is I would use this emission as normal and do 4-bit normals. I'm actually thinking 4-bit normals wouldn't be horrible for a low poly engine or that's only having a few directions. Let me see if I can get this working though. I do want to try to I don't think it's gonna work. Because this is showing, I at least know now with this that when you get close to objects you're gonna get these artifacts. Like that. Yeah, I don't think this isn't gonna work. And this whole thing of screen space normals is really hacky. I don't like it. From all the things I saw looking at this, no one was really able to get perfect normals because you're sort of just approximating based off the presumed change in depth between 2 pixels. Even 32-bit is horrible, float precision bad, only 64-bit plus depth good. Well, that's exactly what I was... So, like, from what I saw, you still can't get 32-bit depth buffer. So, okay, you want to talk about NVIDIA drivers fucking you over? I have seen, like, one of the regular things I've seen is that if you ask for a 32-bit depth buffer, it'll actually give you a 24-bit depth buffer on GPUs. So, oh yeah, dude, 32 bits. If only. Alright, I'm gonna think about this. This isn't impossible. I just need to shift around how I'm gonna encode data. And honestly, the 4 bits per color actually seems insanely good. I'm almost thinking of going down to 3 bits per color. But what I think I'm gonna do is I'm gonna take out emission, and the idea is gonna be that for So I'm trying to think of a way that I can get away without using any bits for emission. Like maybe turning emission. So okay, here's the logic I'm thinking right now for some hacky encoding. Replace the emission part here with the normal. See, here's the thing. I'm actually thinking that 4-bit per normal still isn't going to be enough. 4 bits per normal. Or sorry, yeah, 4 bits per normal is going to be 2 bits for the X and Y, and then you devise the Z from the X and Y. And with 2 bits, that's only 4 values. And you have to have negative in that too. GLES2 for some reason like 4 times faster than GLS3 render in same scene. Reason is GLS2 use 8-bit RGBA frame buffer when GLS3 use 32-bit. Wow, that's weird. So that is completely why I'm actually using my own encoding instead of G-buffers. When I did my own deferred render in Unity years ago, I actually tested between 32-bit float frame buffers and using just regular 8-bit color frame buffers, because there were tons of people that, like today, tons of people say, yeah, just use floating point frame buffers. It's just as fast on modern GPUs. It's not. It's not. The memory bandwidth is actually huge. Alright, I gotta go pee, and I'm gonna think about how I want to encode this now. Oh wait, the music went off. Hold on. plan out how do I want to do this packing. I should actually as well do a little comment here describing gbuffer pixel structure. Alright, so let's work this out. I want at least 16-bit depth. My GPU does not have native 64-bit support, but Vulkan supports 64-bit shaders, so GPU emulate 64-bit, that ginormous slowdown, but for test it's fine. Dude, I feel like that's kind of losing the purpose of GPUs. I compare 32-bit to 64-bit, and 64-bit floats has crazy precious. We need to stop calling GPUs graphics processing units and start calling them parallel processing units. And then just focus on what they're actually good at and doing many, many parallel things. And 64-bit. And a lot of those parallel processes come from doing reduced precision operations, like on 24-bit floats and on 16-bit floats instead of 32 or 64-bit. So it's like, I feel like that's going against GPUs in a way. Red, color green. Type. Comparing it in fractal, the shader, 32-bit float. Do this zoom. Interesting. My GPU doesn't support double. Non-WebGL, of course. Ah. So yeah, I think I'm gonna need at least 4-bit encoding per normal side. So 4 bits will give me 16. See, my difficult thing is encoding negatives, because it won't be even. One side will actually have more precision than the other. you know, operations like POW, sign an exponent, others only support 32-bit. Using double there results in NaN. That makes sense, because those are normally like lookup tables that probably are like lookup tables heavily rely on being a specific type. Wait, is this still too much? 3 times 3, 9, 8, 16. Oh my god, I would need to do 15-bit depth here. It's not what I want to do. Yes, the famous 15-bit depth. Do I want to make one of these lower precision? Lower like the normal Y to 3 bits instead of 4? So, oh wait. So if we get 8 precision, the max value is 7, the halfway point is 3. So the lowest value is -3. The highest value is 4. Honestly, that's not too bad. Nine, 12. And then that'll give me a bit for a mission, I think. See, my other thing I was thinking of doing is if depth is 0, then emission, then the surface is emissive, because emissive surfaces won't calculate any lighting. It'll just be emission. And so setting depth to 0 can encode that, and then you also won't need the depth, because all it's used for is lighting. And if it has no lighting, because you're just using the emission value, then I can encode emission and depth. I don't know, it feels kind of weird just having one normal. Have extra precision. But at the same time, it's like, why not use the full precision? But what I'd really like to do, I think, is make both of these 4 bits. But then to do that, I would need to reduce one of the color values. One of the things I've definitely considered doing is doing a color lookup table, either with a texture or a function, because I feel like that could much more effectively encode many different colors. I wonder if I should like visualize the lower spectrum with only 3-bit colors to see what this looks like. The way I generally look at what these values can hold is I look at what the smallest value is. So with 8, the smallest value will be 0.125, which isn't that high. Or sorry, that's pretty not that low. So I almost feel like I should do maybe linear encoding on these. I'm also thinking, we have more blue I can't remember. If you take away precision from one field, I think it's supposed to be red, right? Red can handle reduction? I don't know. This is hard to decide. I think I'm just gonna go with this. See, but now this won't have the low poly style. I'm almost thinking with this cartoon engine, I should really simplify it. Maybe not do a deferred renderer. Now I'm considering doing a forward render. The thing is, I won't be able to do the volume effects I talked about. But I'll have full color precision and everything. I'll try this and I'll see how it works. Do 2 draw passes to store more data. I'm trying to make this like as simple and as straightforward as possible. Like even for a deferred render, this is pretty simple right now still, just having a single read and a single write, or single single write and then single read when you want to read the G buffer. I'm really thinking about this. I did think I wanted to do a deferred renderer because I was like, oh, it'll allow me to do way more with less. But now I'm thinking about when I'm going for a cartoon renderer, I honestly feel like I probably want to just do the simplest thing. Like, try to really simplify so that it'll fit in a forward renderer. But then, like, that's the weird thing about the forward renderer, is it's like all the stuff I talked about, like fog and all that, you have to fit it all into your single function that calculates lighting or whatever. But at the same time, forward render is like, oh man, I got a limited number of lights. Doing depth passes in Unity's forward renderer means like rendering to the depth buffer and then decoding those depth values, which is like two passes. And it seems like when you render depth in Unity anyways, it does a color rendering. Even though you have color mask on, it's not that efficient. Ah, man. So that's the really nice thing about this deferred system, is you also just get the depth out in a buffer directly, so I can just render this straight to a buffer and use it for shadows. Use the depth for shadows. Alright, I think I'm going to end the stream here. I'm really re-evaluating how I want to do this. Maybe I'll do a forward render pipeline, but then I would have to really change the number of lights, and it almost makes me, the only reason I wanted to do just a regular light system with like sphere and directional lights is the deferred lighting system, where I could go, hey, I could just have 100 pointer sphere lights, and then you can actually do really good lighting even with such a simple thing. But if I'm doing a forward render where I could only have like 2 or 3, at most like maybe 16 directional or point lights, I almost feel like directional and point lights aren't a good way of doing it. Should look into some other things like light probes, because like that's the other thing. I feel like a cartoon lighting system, I don't need to do a realistic. I can just do some sort of like, I feel like a light probe volume where it's lower resolution and sort of smoother lighting might work well. And I also think if there's a way to do sharp lighting, like sharp cartoon or anime-ish lighting. Anyways, thank you for watching. I'll see you around. I hope you have a good one. Bye-bye. I might turn the stream on tonight and do some more development on this, because this whole creating a custom render pipeline has really sucked me in.